now we're going to do our last example, example 4. It says, given the following logarithmic function, h of x equals to 2 log 2. Now my base is 2, keep that in mind, that's a little bit different from what we have seen earlier. Of negative 3x minus 6 plus 4, and the question basically states, asks us to sketch the graph of h of x and also to indicate what the domain and range of h of x will be. Okay, so before we go ahead and start sketching this out, I am going to factor out a negative 3 so I know what my parameters are, and then I'm going to basically look at my key points as well as my transformed key points along with my vertical asymptote to graph the function. Okay, so let's go ahead and do that. So first of all, h of x, going to factor out the negative 3 from there, so I have 2 log 2 negative 3x plus 2 plus 4. Okay, so I'm just going to go ahead and indicate what each one of those parameters mean. This right here is a vertical stretch by a factor of 2. The negative sign here is a reflection in the y-axis. There's going to be a horizontal compression by a factor of 1/3. There's a horizontal shift 2 units towards the left-hand side, and there's also a vertical shift 4 units upwards. Alright, now that we have described this, I am just going to start off by drawing my table values with my key points. Now, keeping in mind my function y, that is going to be my base function, is log base 2x. And then writing that down in an exponential function, that's 2 to the power of y equals to x. And my key points for y is always going to be 0 and 1. And then I'm just going to go ahead and draw my table values for my transform function, keeping in mind that the a and the c value affects my y-axis, so that's going to be 2y plus 4, and the k value here and the d value there is going to affect my x-axis. So it's going to be a negative x divided by 3 and minus 2. Alright, great. Let's go ahead and figure out what those x values are going to be now. Okay, so when y is equal to 0, I'm going to go ahead and plug in a 0 for y there to solve for x. I'm just going to do it on the side over here. So 2 to the power of 0 is going to give me the x value, and anything to the power of 0 is 1. And 2 to the power of 1, which is the y value here, is going to be 2. Okay, great. Now we're going to take those values and we're just going to transform them, and I'm going to use my calculator here because I will get some decimal values. Okay, so bring my calculator here on the side. I have 1, so negative 1 divided by 2 minus 3. Just turn this thing on, clear this. Kind of hard for you to see because of the glare there, but it's just basically negative 1 divided by 3 and minus 2, that's a negative 2.33. And I'm going to do that with the second point as well. So negative 2 divided by 3. And then subtract the 2 there. That's a negative 2.67. Okay, and then I'm going to basically go ahead and transform my y values. 0 times 2 is 0, plus 4 is 4. And 2 times 1 is 2, plus 4 is 6. Okay. Also indicating what my vertical asymptote is going to be. It's always x equals to the d value, and here the d value is going to be a negative 2. So x equals to negative 2. Okay, putting that together. Negative 1, negative 2, negative 3, negative 4, negative 5. And my y values basically has to be positive values, so it's 4 and 6. 1, 2, 3, 4, 5, 6. And I'm going to start off by plotting my vertical asymptote first, which is x equals to negative 2. And then plotting my key points. You just have to be approximate there, so negative 2.33 and 4. Negative 2.33, this is midway right there. It's just going to be a little bit towards the right-hand side of negative 2.5. So it's negative 2.33 and 4 right there. And then I have negative 2.67, which is going to be towards the left-hand side of negative 2.5. So that is negative 2.67 and 6. Okay, so just basically join those 2 points, and it's making the function approach my vertical asymptote. And I'm just going to extend this a little bit further. I know it's going to go over my table of values there. I'm just going to draw myself arrows and indicate or label my function, which is h of x, sorry. So h of x equals to 2 log 2 negative 3x minus 6 plus 4. Alright, great. That's basically the graph. I'm just going to label my axes as well. And then part B says write down the domain and range. So when I'm looking at the domain, I'm looking at where is this function defined, and as you can see from the graph, the function is only defined towards the left-hand side of x equals to negative 2. And it approaches negative 2, so it's not equal to that. So my domain is going to be x such that x is always going to be less than negative 2. X is an element of all real numbers. And then my range is going to be, it spans basically all of my y values. There's no restriction on the y. The y such that y is an element of all real numbers. And that's it for our fourth question as well. Just a few reminders for you guys. First of all, instead of it saying home fun, this should be now school fun. This right is your homework. You can get a little head start on that. We will be working on the homework tomorrow as well. You also need to make sure that you watch the video for lesson 4 on Wednesday evening, which is going to be based on power law of logs. And you basically need to take notes, copy examples down, and be ready to complete your homework for lesson 4 in class on Thursday. Alright, and see you in class tomorrow. Thank you. Bye.